Hello learner, my name is Dickens and we are looking at salts. We are looking at preparation of salts. Our topic for today's lesson is a preparation of salts by the reaction between a metal, carbonate, and an acid. That is what I want us to look at in today's lesson. So reaction between an acid and metal carbonate. So we do that by considering the preparation of lead nitrate. Preparation of lead nitrate. Let's go through the procedure of how we can prepare lead nitrate. So procedure number one is measure about 20 centimeters cubed of dilute nitric acid into a beaker and warm. So we are warming simply to increase the rate of the reaction. Secondly, add a spatula full of lead carbonate to the acid, a little at a time, as you stir until in excess. So we are using excess lead carbonate to ensure that all the acid has been used up during the reaction. Thirdly, filter to remove excess lead carbonate. And then lastly, Roman 4, evaporate the filtrate on a water bath. So that is a brief description of our procedure. Remember, we're reacting lead carbonate reacting with nitric acid. The objective is to produce lead nitrate. So this is what we expect during the experiment. So discussion. So we need to notice this, that during the reaction between lead carbonate and nitric acid, there will be production of some bubbles. Those bubbles will be evidence of a gas, and that gas is called carbon dioxide gas. So the process of production of bubbles of a gas, we call it effervescence. So how do you tell that this reaction is over? You'll tell that this reaction is over when effervescence stops. We have said effervescence means production of bubbles of a gas during a reaction. For this particular reaction, we are considering the reaction between lead carbonate and nitric acid. So the two compounds react. We shall get three products. The products are as follows. We shall get lead nitrate, which will be our salt, aqueous. The other product is the gas, carbon dioxide gas, and this will be evidenced by the effervescence. We have said effervescence is a production of bubbles of a gas. So as the reaction will be going on, you'll be able to observe bubbles, and those bubbles are evidence of carbon dioxide gas, and the other product is water. So we shall get three products: lead nitrate, carbon dioxide, and water. Remember, anytime you write an equation, you should make sure that you have balanced. So we have to balance by putting 2 on nitric acid. So the equation will be balanced. As you can see, we have prepared lead nitrate by carrying out the reaction between lead carbonate and nitric acid. That reaction will give you lead nitrate, which is our salt of interest. We have said during the reaction, somebody can ask you, what will you see? You will observe that there will be effervescence, and effervescence means production of bubbles of a gas during a reaction. When you see effervescence has stopped during this reaction, then it means the reaction is over. After that, you now carry out filtration to remove excess lead carbonate, and then you evaporate. After evaporation, you allow the saturated solution to cool, and after cooling, it will form lead nitrate crystals. So it's also good we mention other salts that can be prepared by the same method, by this method. Include, we have quite a number. We're just going to mention a few. We can have the first one, ammonium nitrate. We can have another one, lead sulfate. We can have another one, Roman 3, magnesium chloride, etc. We have quite a number, but we can pick a few just to illustrate our point. Remember, we are looking at how to prepare salts by reacting a metal carbonate and an acid. So, for example, we look at ammonium nitrate. We can prepare ammonium nitrate by carrying out the reaction between ammonium carbonate and nitric acid as follows. So the equation is here. You react ammonium carbonate. Be careful with the valencies. The valency of carbonate is normally 2, and the valence of nitrate is 1. So our formula should be as follows: plus nitric acid. So this one is a solid, this one is aqueous. So these two react, we get a salt, water, and carbon dioxide gas. Our salt is called ammonium nitrate plus carbon dioxide and then plus water. We have said during the reaction there will be effervescence, and we have said effervescence means production of bubbles of a gas during a reaction. So you will see bubbles. The bubbles will be evidence of carbon dioxide gas. The other salt is lead sulfate. We can still prepare lead sulfate by carrying out the reaction between lead carbonate and sulfuric acid as follows. So we are going to have lead carbonate plus sulfuric acid aqueous. So the two react, we get three products. We get a salt, we get water, we get carbon dioxide gas as follows. Our salt will be called lead sulfate. The other product is carbon dioxide, and the other product is water. Now, you should be very keen with the state symbol for lead sulfate. Lead sulfate is an insoluble salt. As a result, during this reaction, it will come out in solid state. Therefore, we write here solid because it is an insoluble salt. So you check if it is balanced. The equation is balanced. I believe so. Our last example, one more, is magnesium chloride. Magnesium chloride is formed as a result of the reaction between magnesium carbonate and hydrochloric acid. So It's magnesium carbonate solid plus HCl aqueous. That will give you magnesium chloride plus carbon dioxide gas plus water. Take note of the state symbol of magnesium chloride. It is aqueous because magnesium chloride is a soluble salt. So we balance, we put 2 on hydrochloric acid. So Lana, we are saying this, that we can prepare salts also by carrying out a reaction between a metal carbonate and a dilute acid. So you'll get 3 products. You'll get a salt, you'll get carbon dioxide, and you'll get water as the products. And we have said during the reaction, we are going to see bubbles as the reaction is taking place because of this process that we are calling effervescence. So having said that, I want you to try these questions. Try these questions. Okay. Our first question is as follows. You define effervescence. Define effervescence. So try and find out the definition of the word effervescence. We have said is a process that takes place during a reaction. So our first question is define effervescence. Our second question is write balanced equations. Write balanced equations for these reactions. We are supposed to write balanced equations for these reactions here. The first reaction is the reaction between calcium carbonate and hydrochloric acid. Try that. The next reaction is reaction between lead carbonate and hydrochloric acid. The last reaction is between magnesium carbonate and sulfuric acid. So Lana, we are saying you write balanced chemical equations for these reactions. Calcium carbonate reacting with hydrochloric acid, find out the products. Lead carbonate reacting with hydrochloric acid, find out the products. And magnesium carbonate reacting with sulfuric acid, find out the products. Now, having said that, I want us to look at another method of preparing salts, a very brief one. Very brief in the sense that it just involves direct equation or direct combination. Remember, you're learning about methods of preparing salts. So we are looking at another method where we combine elements directly. The elements are a metal and a non-metal. So our next method is called preparation of salts by direct synthesis. Preparation of salts by direct synthesis. So direct means we are just combining the elements that form the salt directly. So we go straight. So direct synthesis means combination of elements directly, and in most cases These elements are a metal and a non-metal. The two are meant to combine directly. As a result, we shall come up with a salt as a result of the combination of the two particular elements, a metal and a non-metal. Let's do that by considering these equations here. Before that, we need to give examples of such salts. Examples of such salts. Examples of such salts include iron 2 sulfide. This one is called iron 2 sulfide. Iron 2 sulfide. The next example is sodium chloride. I'm sure you are familiar with the name. This is sodium chloride. Sodium chloride. Sodium chloride. Our last example is iron 3 chloride. Iron 3 chloride. So these are examples of salts produced from direct synthesis. Let us look at it in terms of equations. The first one, iron 2 sulfide is formed when iron reacts with sulfur. So this will be the reaction. Iron plus sulfur. These two will react. We shall get iron 2 sulfide. Remember, we have said direct synthesis involves combining a metal and a non-metal directly. Iron is the metal, sulfur is the non-metal. The two combine directly, and then we shall get a salt, and this salt is called iron 2 sulfide. The next example, sodium chloride. Sodium metal combining with chlorine gas. This will give you a compound by the name sodium chloride, and that is our salt. Take note, the equation should be balanced. So because of the 2 atoms of chlorine on the left hand side, this side should also have 2 atoms of chlorine. So we balance, we put here 2. The 2 means I'll have 2 sodium atoms on the right, but the left has 1. So I balance by multiplying here by 2. So the equation will be balanced. Once again, this is our metal combining with a non-metal. So the 2 combine, we get sodium chloride, which is our salt. And then lastly is iron plus chlorine gas. Iron can also be made to combine with chlorine. Remember, these reactions require some heat because the 2 elements cannot just combine when they are cold. So we have to carry out some heating to speed up the rate of reaction. So these 2 will combine. We shall get a compound which is called iron 3 chloride. We have to balance the equation. I'm having 1 atom of iron on the left and 1 atom of iron on the right, but 2 atoms of chlorine on the left and 3 on the right. So we have to balance. We make this number to be even. So I will multiply this one by 3 so that I make it even. So I'll have 6 atoms of chlorine, and then also make this chlorine to be even. So I multiply this one by 2 so that there will be 6 chlorine atoms here. Then it means I'm having 2 atoms of iron. So I put here 2 like that. So the equation will be balanced. You can see we are preparing iron 3 chloride by combining iron and chlorine. So iron is the metal, chlorine is the non-metal. The 2 combine directly, therefore the name direct synthesis. Synthesis means to produce. So we are producing salts by combining elements directly, and we have said we combine a metal with a non-metal. That will give you a salt. So that is all about preparation of salts by direct synthesis. It's also good we know the colors. Sodium as a metal is normally gray in color. Chlorine is a green-yellow gas. The two will combine, we shall get a salt, and this salt is white in color. Iron is gray in color. Sulfur is yellow in color. The two, when they combine with some heating, we shall get black solid of iron to sulfide. Iron is gray in color. Chlorine is green yellow in color. The two combined, we shall get white iron 3 chloride. So that is all about preparation of salts by direct synthesis. So I want you to try this question here. The question reads, what is meant by direct, what is meant by the term direct synthesis? So learner, we are saying you try and define what the term direct synthesis means. So what is meant by the term direct synthesis? Second question, what is the color of the following substances? What is the color of the following substances? It's good we know what is the color of the following substances. First one, chlorine gas. Secondly, iron filings. What is the color of iron filings? And then lastly, the color of sulfur powder. So that is the end of our lesson for today. I thank you for being a good student, and I want to say we shall meet in the next lesson.